Let us observe one simple example to retrieve an quadratic equation. For suppose, a hole having an area of 400 meters, with length 1 meter more than 7 times its breadth. Solution. Step 1. As the length of the hole is more than the breadth of the hole, let's assume that the room is in rectangular shape. Step 2. Assume x be the breadth of hole, that is, breadth equals x meters. Step 3. Given that the length is 1 meter more than 7 times the breadth of the hole, then we can write length as length equals 7x plus 1 meters. Step 4. As we know that area of a rectangle is length into breadth, meter square. Step 5. From step 3 and step 2, area equals 7x plus 1 into x, meter square. Step 6. Given that area of the hole is 400 meters square. Step 7. From step 5 and step 6, we have 7x plus 1 into x equals 400. This implies that 7x square plus x equals 400. On rearranging the terms, we have 7x square plus x minus 400 equals 0. On comparing the above equation with the general form of the quadratic equation, that is, ax square plus bx plus c equals 0, we can say that the derived equation is in the form of quadratic equation. Before we move in detail about quadratic equations, let's see the history of quadratic equations. History of quadratic equations. Babylonians were the first to solve quadratic equations. They knew how to find two positive numbers with a given positive sum and a given positive product, and this problem is equivalent to solving a quadratic equation of the form x square minus px plus q equals 0. Greek mathematician Euclid developed a geometrical approach for finding out lengths, which is in our present-day terminology, are solutions of quadratic equations. Brahmagupta, AD 598 to 665, gave an explicit formula to solve a quadratic equation of the form ax square plus bx equals c. Sridharacharya, AD 1025, derived a formula, now known as the quadratic formula, as quoted by Bhaskar II, for solving a quadratic equation, by the method of completing the square. Abraham Bahiayanase gave complete solutions of different quadratic equations, in the book he published named Liber Embadorum in Europe, on AD 1145. Let's now learn quadratic equations in detail. A quadratic equation is an equation equivalent to one of the form ax square plus bx plus c equals 0, where a, b, and c are real numbers, x is a variable, and d is not equal to 0. Ax square plus bx plus c equals 0, where a, b, and c are real numbers, x is a variable, and d is not equal to 0 is referred to as the general form of the quadratic equation. Let's do some examples and check whether they are in the form of quadratic equation or not. Example 1. 2x square minus 3x plus 1 equals 0. On observing the given equation, that is, 2x square minus 3x plus 1 equals 0, we can say that 2x square minus 3x plus 1 equals 0 is a quadratic equation, because it is in the form of ax square plus bx plus c equals 0. We have also noticed that the highest degree of the given equation is 2. Note, always the quadratic equation is in the form of ax square plus bx plus c equals 0, and degree of a quadratic equation is 2. Example 2, check whether 7x plus 2x square minus 5 equals 0 forms a quadratic equation or not. Solution. Given equation is 7x plus 2x square minus 5 equals 0. Rearranging the given equation, we have 2x square plus 7x minus 5 equals 0. From the above equation, we observe that 2 is the highest degree of x in the given equation, and also we observe that the above equation is of the form ax square plus bx plus c equals 0. as the highest degree of the given equation is 2, and the equation is of the general form of the quadratic equation. We can say that the given equation is a quadratic equation. Note, always the terms of polynomials should be arranged in descending order. Let's check the following problem, whether it satisfies the representation of quadratic equation mathematically. Veena and Vani together have 40 chocolates, both of them lost 4 chocolates each, and the product of the number of chocolates they now have is 130. Let X be the number of chocolates Veena had. We know that together they have 40 chocolates. Then, the number of chocolates Vani has equals 40 minus X. Since, given that, Vani and Veena together equals 40 chocolates. If Veena have X chocolates, then Vani should have total minus Veena's equals 40 minus X. The number of chocolates left with Veena when she lost 4 chocolates is X minus 4, make it as equation 1. The number of chocolates left with Vani when she lost 4 chocolates equals 40 minus X minus 4. This is equal to 40 minus X minus 4. This is equal to 36 minus X, make it as equation 2. Given that the product of chocolates both have is equal to 130. Therefore from equation 1 and equation 2, we have X minus 4 into 36 minus X equals 130. This implies that X into 36 minus X minus 4 into 36 minus X equals 130. This implies that 36x minus x square minus 144 plus 4x equals 130. Rearranging the terms, we have minus x square plus 40x minus 144 minus 130 equals 0. This implies that minus of minus x square plus 40x minus 274 equals 0, since we are multiplying the expression with minus. This implies that x square minus 40x plus 274 equals 0. Therefore, the number of chocolates with Veena and Vani satisfy the representation of quadratic equation mathematically, as the derived equation is in the form of ax square plus bx plus c equals 0. Let's check few more examples.